Good afternoon, everyone, and thank you for joining us today for the first day of the 3-day Stormwater Management webinar series. And this is Penny Poley, and I am the Conservation Training and Membership Services Manager at Wisconsin Land and Water. And I'm very happy to host our series of stormwater practice maintenance and different webinars that we're going to be offering. Today we have, I think, about 5 presenters that will be giving their different presentations on their PowerPoints. And Leif from Waukesha County will be giving you an overview of that when he comes on. I think that's about it. That's all that I have. But now Leif is going to tell you a few things about today's presentations.
Thanks. This is the 20th annual stormwater workshop that my department has hosted. So it's our, I think that's the Emerald anniversary, if I remember correctly. Most of the presentations this year are going to focus on stormwater BMP maintenance. After our workshop last year, and then again when we met with our municipal partners, that was the single thing that got the most requests. So we decided to focus on that. Although there will be a few other presentations as well on regulatory updates and some other topics. Instead of trying to pack everything into a single day like we do with our physical workshops, we opted to split it into 3 afternoons, partly to try and ensure that as many of our presenters would be available as possible, and also so that in hopes that the audience would also be able to attend as many as possible. We thought if we went with a single day, we would lose a lot of attendees and also presenters. After the workshop, we're going to post the presentations as PDFs on our website. I believe we'll send a link to that when we send the PDH certificates as well. I'm going to give a short background on each of the presenters. My own background is that I have a master's in civil and environmental engineering from Michigan Tech in Houghton, Michigan. I've been working for the county since 2001. Previously, I was an environmental consultant for 10 years. I have a professional engineer and professional hydrologist certificate in Wisconsin. The first presenter is Pete Wood. Pete is a water resources engineer for the DNR out of the Sturtevant Service Center. He's been with the DNR since 1991 and is currently responsible for construction site stormwater permits, municipal stormwater permits, and urban stormwater grants. This is the first time ever that Pete has not been alphabetically the last speaker. So he's going to talk about the DNR's perspective on BMP maintenance for about 20 minutes, and then he's going to give an update on the dewatering tech standard for about 10 minutes. So, Pete.
Thank you, Leif. Thank you for having me back in these strange circumstances. So I'll go through quickly the first presentation. Well, this one will be a little longer. This will be about 20 minutes. So what I'm going to talk about as far as stormwater management, best management, how DNR fits into the picture, regulations, a little touch on some of the research that I'm aware of that is related back to stormwater practice maintenance, and then just my personal troubleshooting experiences with various practice failures, and hopefully some lessons learned with that. So let's charge ahead. I did want to mention, Leif, you mentioned it too, you know, you guys have been doing this for 20 years, but it was 10 years ago that you did a really intensive BMP maintenance day. So it's interesting, it's been about 10 years. And I was thinking about that a little bit, that, you know, hoping, you know, that we made some progress. I think we have, but maybe not as much as we need to. So I'm going to highlight a lot of that. And obviously best management practices have continued to be in need of maintenance over the last 10 years. So here's kind of the picture of the way the department regulates long-term maintenance for stormwater. So we have our construction site stormwater permit program that's been in place for the last 25 years. And this would be construction sites. Initially, construction sites that disturbed more than 5 acres of land, and now obviously the last 20 years it's been 1 acre and larger. So it's essentially what the code has always required is long-term maintenance provisions for new development and redevelopment where there's going to be permanent stormwater practices in place. The second branch of our regulatory structure is our municipal stormwater permit program. Very active in southeast Wisconsin for, again, about 25 years, range in permits, individual permits from the mid-90s up till the last 5 years after the most recent census. So about 110 municipalities in southeast Wisconsin fall under this program. There's really two elements of that permit that tie back into stormwater practice maintenance. One is stormwater. They have required to have a stormwater ordinance to regulate new development and redevelopment the same way DNR is. And then they also have what we call the pollution prevention program, which is a number of different practices, but includes BMP maintenance, inspection and maintenance as part of that. And I added in the third element, even though it's not technically a regulation, they're only guidance documents, but we have our post-construction stormwater technical standards that include, all of them include recommendations for long-term inspection and maintenance of all these various practices. So that's kind of like the basically the overview, but I'm gonna dial this down a little bit for each category. So here's a summary of what the construction site stormwater permit requires regarding long-term maintenance. Basically, you have to have some kind of, it's going to be applicable to any new development or redevelopment, again, where there's going to be these long-term stormwater management practices in place, ponds, biofilters, permeable pavement, etc. They're supposed to have a inspection and maintenance plan developed per our DNR technical standards. Again, we use the tech standards to help people guide what those plans look like. We don't actually have a set long-term maintenance plan, so a lot of it is professional choice as far as what they look like, but we have some guidance, obviously. The third element of that is that there has to be a maintenance agreement with the local unit of government. So a legally binding document that carries over with the property in relationship to the municipality. At the front level, those agreements are usually requiring the owner of the practices to do these activities, but allows the municipality to come in and take over if needed. That's usually how they're set up. But there's some different variations that we might get into also. And then finally, under the current regulation, we want these plans, both the maintenance plan and the agreement, to be submitted with the DNR permit application through the e-permitting process now. As you go, I mentioned we've been doing this for 25 years. As you can imagine, if the farther you go back in time, the less quality information we have. And there's a time back when we first started doing this, the application was just simply a two-sided piece of paper. So we don't always have hardly any of these documents going back in time. People ask for them, and we may not even have them up until more recent years. So even at DNR, it's kind of a mixed bag of what we actually have or could provide to somebody. But the main point is that over the last 25 years, this, in theory, has been required for these projects. So now I'm going to go into the MS4 permit program. Again, about 110 municipalities in southeast Wisconsin are covered under this permit. So not the entire region, but there's a lot of crossover here, especially for these permitted communities where they're doing a lot of the same things we are with this. So number one, again, they're supposed to have a post-construction stormwater management ordinance that governs development the same way we do, and then can also include some other things like peak flow control and things that we don't require, but generally in one big package. So relative to long-term maintenance, they're supposed to have long-term maintenance provision requirements in their ordinance that would go establish what, let's say, a developer, an owner of a facility needs to do. Also part of this requirement, not only the provisions in the ordinance, but that they enforce whatever kind of agreement they formed with the developer or whoever owns the practice. It is going to be applicable to new development and redevelopment that were permitted after the ordinance was adopted. So that's where it's kind of like a really mixed bag in southeast Wisconsin. I mentioned, we started permitting municipalities back in the 90s, and then there's been kind of different phases over time. So that means, unfortunately, there's not like one date that this applies to. It really kicks in whenever a permitted municipality adopts their ordinance for the first time, has these DNR requirements in them, and they first issue a permit under that ordinance. That's where this requirement kicks in. So they're supposed to enforce these ordinances on those developments going forward. So again, unfortunately, this could be a different date for every community. We could probably help. We should be able to help if the community doesn't know what their first date was. Hopefully that would be in their ordinance legal records on what that date is or when their first permit was issued under that. We may be able to help with that, but unfortunately, that means it's kind of a mixed bag of when communities are enforcing these long-term maintenance provisions. The other element of the MS4 permit where this comes in, and this may or may not be related to the previous one, is that they're supposed to have their own inspection and maintenance program for municipally owned stormwater practices. Regional detention ponds would be an example, and also private practices that they've included in their stormwater modeling, their water quality modeling to meet NR 151.13, to meet TMDL requirements. That's been a big thing in Wisconsin or Southeast Wisconsin recently. So there's special provisions for the practices that they're using to meet their water quality standards, essentially. They're supposed to have an inventory of these practices, mapping, right? They're supposed to inspect these practices or have someone inspect those practices at least once per permit term. And a permit term is 5 years by definition, so once every 5 years. They're supposed to keep records of all the activities that incur maintenance and inspection and enforce these agreements, right? Similar to the other track that we were on with the new development, this is also another track for these modeled practices, basically, and also keep records. Okay, now this is kind of the new this is the language from the new general permit, but it's going to be incorporated in some of these older permits. So if you're a community rep, if your permit is some years old and it's due for reissuance, you may have some slightly different maintenance requirements that don't match up, but at some point in time they'll all kind of come to this level. They'll take some time to get there. So private practice maintenance has been a big issue. I'm going to talk a lot about this, but what are the options for a municipality? And they're not great. The first one is to let the owner of the practice do it themselves as far as inspecting, maintaining it with some oversight from the municipality, more from an administrative standpoint. We know that's difficult. Every time I think anybody who's represented a municipality has talked to somebody at a homeowners association, many times they don't know what they have. They don't know what to do. They don't have any money, and we'll get into that a little bit too. So there's a risk of letting an owner of facility do everything themselves with just some high-level municipal oversight. The second option is to actually have the municipality do it themselves, and I know many have because they've given up on the first option, but that comes along with another issue of there's a cost involved with municipality doing it themselves and staff time and other things. So that may not be the answer. I just threw in the possible option of a third party. Maybe there's something else. Maybe there's other groups. I don't know if nonprofits would be interested, but maybe there's another way to think about this, because I think the first two come with their challenges. And is there another option or some kind of hybrid? So I'm just throwing that out there. I don't know the answer to this question, but just a thought on how to move forward on some of this stuff. So I'm going to tie this back in, just talking about some of the problems that we see with long-term maintenance, implementing both the DNR rules and the municipal rules. And number one, I touched on this a little bit, responsibility is, a lot, especially homeowners associations, they don't know what they have, they don't know what to do. Finding someone to do it is a challenge, and this has not changed. So it'd be nice to really try to answer this someday. And again, with looking at some of those other options, different players getting involved, but that's a big deal. Number two is funding, and this also it ties into the first one and to municipal funding is having the money to do, let's say, a pond dredging, which can be significant. I think very few homeowners associations have saved enough money. Municipal budgets are tight. Do we have the money to actually maintain practices? Third is actually finding experts or contractors that can do this kind of work, both inspection and actually maintenance. I've talked to a number of contractors. Some of them have indicated they could do it. It doesn't seem to be, as far as like the heavy maintenance, I'm talking like pond dredging, it doesn't seem like there's a lot of options out there. So this is kind of a thing that maybe DNR can help with, is over time someday develop lists or provide some list of contractors can do this kind of work. Maybe that's one way we can help. And finally, record keeping. And we've talked with a number of municipalities that are doing a pretty good job of maintaining practices, but not good at record keeping. So we always emphasize, if you didn't keep a record of it, how does anybody know you did it? So this is, the most important thing is things getting maintained, but we always emphasize also the idea of keeping records to show you what you did. So how about some solutions? One is actually just doing some more outreach to owners of practices, both commercial and residential, so they know what they have and what they need to do. Craig Helker is going to talk tomorrow. He's one of my coworkers. We did a presentation for some homeowners in Franklin a couple of years ago. I think it went pretty well, but it did help emphasize I don't think they understood what they actually had or what the responsibilities were. So I think that would go a long way, is some education to owners of practices of what they have, what they can do, how much it costs to fix things up. Another idea is identifying co-benefits. What I mean by this is sometimes, especially like for maybe municipal elected officials, that it's not just something DNR wants, that these stormwater management practices have additional benefits, whether it's aesthetics or flood control. And if it's an issue of trying to find funds, sometimes you have to think about that these practices are more than just removing stormwater pollutants. They have a number of different things, and that can help get support. Sharing equipment, I actually just talked to a contractor this morning. We got on this topic, and he brought this up, the idea of, especially for like pond cleanouts, hydraulic dredging. That might be some kind of a situation where a group of communities could buy hydraulic dredging equipment and do it themselves. That's just an idea. I don't know if it's feasible or not, but it's just a thought of communities working together, sharing equipment when they're getting in the game of doing the maintenance themselves. Planning for funding, and that could be both. And I think John Seatman is going to talk about this kind of stuff too. Is like thinking ahead, having resources available either from a developer standpoint to actually fund long-term maintenance of practices, or from a municipal standpoint, putting money away so that you can pay for maintenance when it comes up. And then the third one I'm going to mention is, this is really important too, and this involves DNR, is having maintenance-friendly designs. We'll talk a little bit later about what I'm seeing out there, but there might be ways of designing our practices so that maintenance is easy. We always thought about that, but trying to focus on that might be important moving forward. Just going to talk a little bit about a couple of research occurrences that have come up that I've become aware of that may impact maintenance. There was some research that came out of Minnesota last year talking about that stormwater ponds are actually becoming a source of phosphorus. We always thought, it's been the most common practice, especially in this part of the state, for many years to remove pollutants, but what if it's a source of phosphorus? And there was a talk at last year's Waukesha conference about sediment in streams being a source of phosphorus. So this is similar results, that the sediment sitting in the bottom of a stormwater pond can release phosphorus over time under certain conditions. So it does emphasize that maybe, and we'll see where this plays out, but if someone is really interested in reducing phosphorus for TMDLs, if the pond's an actual source of phosphorus, it may make the frequency of cleanout more important. So there's some up and coming stuff on that I just want to make you aware of. The other thing I want to touch on is this idea we've talked about, what's the role of plants, wetland plants. Most stormwater ponds that aren't being maintained to remove vegetation have some sort of a safety shelf with some sort of wetland plants growing in it. Are they good or bad? This research kind of suggests that it might be somewhat neutral, that they may be removing phosphorus in the growing season, but then releasing it in the winters we have here. So we'll see where that ends up if we end up changing our maintenance requirements to have people try to get rid of the biomass. That's a whole other subject, but whether we would consider doing that in phosphorus areas, removing the dead vegetation. This is one of the reasons why maybe floating wetland islands is a good strategy, because they can be put out in the growing season and pulled back in the winter, and that kind of hopefully takes that loss of phosphorus out of the equation. So more to come on that sort of thing. I just wanted to mention it.
Pete, you're at about 5 minutes.
Okay, thanks, Leif. I'm going to quick speed up a little bit. We've learned a lot at the permeable pavement research facility in Madison over the years. This is more than just permeable pavement. I think it applies to any kind of filtering practice. But what we know is that, especially permeable pavement, is that it clogs very rapidly the larger the run-on surface area. So this would be the area of, let's say, conventional pavement draining to the permeable. The larger the conventional pavement area is relative to the permeable pavement, the faster they clog. And there's probably some logic there, right? But I think this plays out to any practice that's a filtering practice, whether it's biofilters or some of the cartridge filters that are available. they are susceptible. The larger that kind of, I guess, with run-on ratio. So we may end up doing something on that, but it's something to think about. There's other aspects of the research in Madison that we're learning. The different techniques for cleaning, let's say permeable pavement, things with air followed by vacuum or water followed by vacuum work really well. But you'll see more on this. I don't have a lot of time to touch on it, but interesting stuff that's coming out of that study. So a little bit of troubleshooting, give you a couple of my experiences. I get a lot of calls from people about ponds, and it's mostly homeowners arguing about who's going to pay for the fountain running or who's going to pay for the chemical treatment. And then at DNR, though, we talk mostly about the function as a pollutant removal. And whenever I ask someone, does anybody check the bottom sediments? Usually the answer is no. So we know, these ponds have been around. Some of them are, 25 years old or older. They're probably filled up. I just don't get a lot of calls from people asking about dredging. So I don't know how much is actually happening, but they probably are due. We do have a administrative code that gives people guidance about how to deal with the sediment that comes from a stormwater pond, is the NR 528. But again, a lot of the calls I get aren't about the dredging. And I think that means nobody is really considering that. But it does have an effect. A pond full of sediment does have effect on the aesthetics as far as algae growth and plant growth goes. I just want to talk a little quickly, just throw this out there, biofilters. I don't know what to do with the vegetation is. Some of you have probably seen this too. They're all supposed to be planted. Whenever I go out and look at them, a lot of times I don't see any plants at all. So I don't know what that means, but I do know the plants are important. Maybe not for the pollutants, but for, I think, keeping the pore spaces open. So this is at Drexel Town Square in Oak Creek. This is a biofilter, but it has stone on the top. And this is one that was suspected wasn't draining well. They flooded the biofilter to check the drain down time. It was around 3 inches per hour, which is kind of our criteria, but for a brand new biofilter that's mostly sand, it should really be better than that. So I have my questions about a biofilter that has stone rather than plants. I think the plants help. That's just one example. I've been called out to a number of biofilters that aren't draining properly. The one on the left with the ducts is one that where the underdrain was actually had tailwater on it. It was under the water from the ditch in the railroad over there. So just that's more of a design consideration that these things need to drain, and an underdrain that's underwater is not going to work. This is the one on the left is an infiltration. I'm sorry, on the right is an infiltration basin that was constructed in groundwater. I don't know how to solve these problems. Some of these basins are to the point where I don't know if you can bring them back, so they become what they become. But again, hopefully, we can create situations where you don't have a unsolvable maintenance problem. Here's an interesting one. MMSD built a big biofilter on the north side of Milwaukee. Was having problems draining. It wasn't real obvious. You can see in the pictures. I mean, there was a little bit of water when you walked around it, but this is around a double ring infiltrometer test, so they saturated it. The interesting thing about this one is that they filled up both rings and it didn't move at all. The infiltration rate is 0. Really hard to diagnose. They sent the engineered soil in for testing. There was some questions about it, but in the end, this biofilter had flap gates on the underdrains to prevent, the idea was to prevent a backflow from the storm sewer system. It was actually preventing the biofilter from draining. So they removed the flap gates and this one's working again. So that was just an interesting case. Here's another one. This one's in Racine. I've shown this picture before. This was supposed to be a sand filter. It never has been one. This is one where there was discovered later a base flow from the storm sewer system that kept this thing completely saturated. So again, like the biggest enemy of a lot of these filtration practices is continuous water. Finally, I just want to mention there's a lot of underground filters that I've been seeing in permanent applications, upflow, storm filter, there's more on the market. The problem with these is gonna be the maintenance and we have tech standards coming out to deal with these proprietary filters, but it's gonna require regular replacement of these cartridges, possibly even more than once a year. And so I'm wondering, even though they seem to be convenient and work for people on certain developments, whether people are up for the maintenance that it requires. So it's just something to think about. All right, Leif, I think I got it. We can take a few questions.
Sure. I'm not seeing any chat questions, so we'll give people a chance to see if they can think of some quick here. In the meantime, I have 2 questions I can think of. One is, you know, it seems pretty clear that for privately owned BMPs, it's a requirement that people have a maintenance agreement, and that presumably it has to be recorded with the local register of deeds in order to be enforceable. What's the DNR? Are you expecting that municipalities should not just have a plan for them, but also have some sort of recorded document?
No,
And
yeah.
enforceability is an issue.
Yeah, we haven't been requiring municipalities to sign an agreement with anybody. So no, we've been just handling it as they just have to have an inspection maintenance plan, but not actually have an agreement with anybody. We can talk about that if that's necessary. I guess we've thought it isn't necessary, especially for the permitted MS4s where we have a permit. But that it does raise a question about the non-permitted MS4s and how we would deal with that. Good question.
So for municipalities, basically, if there's a binder on a shelf and it's got the plan and it's being implemented, that's good enough.
Yeah, that's what we've been doing. I did want to make now it's slightly different, but I did want to mention that DNR, we never developed a template or a model for long-term maintenance agreements or plans. But the one that Waukesha that you guys have in Waukesha has been one that I've shared whenever someone asks, and I see it being used around Southeast Wisconsin and other communities. I think it's a really good document. I'm not sure if there's interest for us doing that at DNR. I mean, we've talked about it, but we never followed through on it. I guess I would be interested to see if anybody wants us to do that. But in the meantime, whenever anyone asks, I usually give them the Waukesha County version.
Well, that's very flattering.
Do you want me to give you some money? I don't have any, but
Yeah, we should have copyrighted it.
Yeah.
The other thing I had was you showed a bunch of pictures of failed bioretention basins. My own hypothesis is that the convention seems to be to wrap the drain tile in geotextile to keep sediment out of it. But I suspect that the geotextile is very susceptible to getting plugged with fines, and it may be that there's drain tile, but nothing's actually making it into it.
Yeah.
Yep. Yeah. What do you think of that?
I think so too, and I know we had a real interesting debate during development of the permeable pavement tech standard about that. And it's kind of a professional choice. I mean, we had folks on our committee who were really liked having the sock around the tile, and some that didn't. So I think we don't encourage it. I don't know if we absolutely ban it, but I'd have to look at our documents again. But it's not encouraged that the under drain is wrapped in a geotextile, because the thought is that it is kind of a failure plane. And actually at that Drexel Town Square, that's what I was thinking, because underneath that larger stone, they have a geotextile and then the engineered soil. And I was wondering if the geotextile was kind of like the clogging surface on that one.
A few years ago at a StormCon, I think it was, I saw a presentation where they were advocating using geotextile, but just as sort of a roof over the drain tile, sure, and then leaving it basically open on the sides, but with 4 inches of stone or something.
I've seen that. Yep, I've seen that. Yep, that might be a good compromise, right?
Yeah. We do have one question. What do you recommend for BMPs that were constructed before any maintenance agreement was needed? Are maintenance requirements specified on a plat enough to enforce or include in a municipality's model?
Yeah, we've been talking about that a lot. I don't know if we know the answer to it. The only thing the DNR's expectation is that the municipality is able to get and establish some sort of maintenance authority. I know different municipal attorneys have different opinions on that from what we've heard. But I think if a municipal attorney would say that we have all we need to be able to go on a property and do an inspection and do maintenance, we have to, that would be enough for DNR, right? But it is, and Leif, I know you guys have talked about this too, that it's very difficult dealing with older facilities, and maybe not even really old ones, where the agreements just aren't very sound, right? Or might not be with anybody who's still like, the old homeowner association issue where they go defunct and then it's not valid anymore, So that's kind of like you could probably spend a whole day talking about that,
Perry, my supervisor, sent a text saying that then you need a BMP maintenance ordinance. There's a model on our website.
Yes, right. We've been promoting that also. If anybody doesn't know about it, is Waukesha County developed an ordinance that could be used to go back in time, right, Leif? I mean, that's basically the idea. Go back in time and take some authority over these older practices. I think it's conditional though, right, that they had some kind of a permit authority at the time, right, Leif? I think that's, but again, every municipal attorney can maybe take a closer look at that, but we really promote
Why
that.
don't you go ahead with your
Sure.
update on the standard?
Sure. Yeah. So now for something completely different. We've been doing a modification, updating of the dewatering text standard that hadn't been looked at since it was first drafted, basically 15 years ago or so. So we've been doing that a lot. I mean, you've probably been seeing a lot of notices on the different text standards we've been updating. So this is just the latest, and it's going to be reposted on our website very soon, the new version. So I'm just going to go through a quick highlights, not spend a lot of time on this, but a lot of it was shifting things around. So the one thing that was done was consolidating kind of the discharge location criteria that was with each practice. Again, the dewatering practice text standard is an interesting one because it's really not one practice, it's a whole bunch of practices. So what we did was consolidate the things like don't put your filter bag on dirt, don't discharge to dirt, it's that kind of stuff, right? So we put that all in one spot. We added some criteria about internally drained areas and trying to use those, which I think people have been doing anyway. But we actually made a whole section on you don't really need to treat your dewatering water if it just sits on the site in some other hole. That's really the idea. But we have some criteria that people need to think about when they're doing that. So we're really promoting the internally drained concept, and that if it's appropriate internally drained area, you don't have to do any other kind of treatment prior to the discharge. Made some updates to the geotextile criteria, modernized it a bit. We added some criteria about dewatering wells, because that's always been a confusion. When people talked about dewatering, they always thought it was wells. The text standard is really for more like the trash pumping. Throw a pump in a pit and trench and pump out the dirty water. There's always been confusion about where dewatering wells fit in, so we actually created a separate section on that. The text standard will now promote combinations of practices. I think we've learned maybe the hard way that it's, treating dewatering water is very difficult, especially clay, soil particles. The technologies on their own probably can't do it. Like the old, the filter bag has been the most popular. We don't think with the fabrics that we're speccing out that it's going to work for clay, but we're giving the people, contractors some options here and promoting use it in series with something else, whether it's using, we're promoting more of using the water applied polymers prior to the bags, using bags in combination with the settling, some other concepts. So we're trying to push that. The whole operation and maintenance section was expanded because that's really important for these operations. We're treating it more like the track out control, that you can't inspect a dewatering operation once a week or after a rain event. It could be happening any given time. We need people to be looking at it on a daily basis. So the O&M section kind of gets to that, and it emphasizes some different things to look at for the different practices. We added an evaluation criteria, which I'll talk about a little bit later, show you the diagram. We have that. So in other words, we're trying to get people to move to the next step to help them make some better decisions on when whatever they've tried isn't working. And then we added a bunch of figures. So that's what the next sequence events is, all the new figures, thanks to Kim Gonzalez in our Madison office for putting these together. So we added, this is a geotextile bag. We added this kind of a concept of the water applied additives, mixing hose, try to show people how this can be done. It can be done in many different ways, and we're encouraging people just to work with the suppliers on that, but we try to do probably a visualization of using polymer prior to a filter bag. That's just one of the examples. We kind of modified what used to be the DOT filter basin with the straw bales. We're calling it more of a geotextile filter basin, and emphasizing the filtration, because a settling area made of straw bales isn't really deep enough to prevent resuspension. So we're focusing more on these things being a filtering, like an open air filter bag, basically. So you've got to put it onto some kind of permeable material. It could be made with the sides made of straw bales, but the bottom should be made out of some kind of aggregate to allow that water to pass through, because we know water doesn't really pass through the straw bales. So it's focusing on using that fabric, water filtering through the fabric, and that's what's doing the work as far as the sediment control goes. This is something that came up during our broad review, the dewatering channel concept. And I've seen this used before, but we're focusing on that if you're going to use it in this way, like a channel, basically putting like little, they can be made out of different things, more or less ditch checks, but they actually have to act like filters. So the water in this exhibit is trying to show water passing. It's not going over the top like a ditch check. It's actually running through either like a geotextile filled with something, or it could be some other product. So it's the filtering through the device, it's not like a ditch check. So that's what that is. We also showed this concept. This is something Madison's been using. It's kind of like a dual technique using a dumpster. The first part is a settling tank, and then the second part is these filter baffles made of geotextile. So we wanted to put them in there. Again, trying to give people better ideas, things that we think have been working. So we threw this thing in there. This is what I want to talk about finally, because we want people to, in this daily evaluation, take some water samples from the discharge, from whatever they're using, and make some kind of judgment whether it's working or not. It's not a water quality standard, it's more of a decision-making tool. So what they should do, or can do, is print out this sheet, cut out this Seshi disc, put it in the bottom of a mason jar. What you're supposed to do is look down through the top, through 5 inches of water. And if you can see the Seshi disc, then you're good. If you can't, then you got to change your practices. So that's kind of what this is. We're going to experiment with this. I mean, we've never tried this before, but the hope is that people will make better choices when they're doing dewatering and know when to make a change. That's the concept. And that's it.
I like that the Secchi disc test. That seems like a real, very easily implemented.
That's the whole point. The point was, it's not really. It's kind of a crude technology, but we thought, that should be close enough to make people feel like, yeah, am I doing okay or not? And then making some decisions. And hopefully the tech standard is drafted in a way that it can help people make that next choice. Again, if you're using a filter bag in clay soils, it's not working, go to water applied polymer, or use it in conjunction with a settling device or something like that. So that's the idea.
If people do add polymer, at what point do they need to go through some kind of permit process for that?
Well, they don't need to go through any permit process, because we have any product that's used in Wisconsin has to have a use restriction letter from DNR. That's a different part of DNR who basically make sure the product's tested so that it won't hurt aquatic life. So this has to be it has to have a use restriction letter from DNR to be used in Wisconsin. That's really the only thing we say. And we have a list of those products. There's a link in the tech standard where we keep that list. So that's all we're asking is people make sure you use a product that has a use restriction, and then use it within the use restriction. Other than that, that's all we are asking. But there's a process. If someone has a product, like they've invented a product, there is a process to get on that list. There's a pretty extensive list. So
on your on the diagram with the bag, I noticed that you had a port for injecting additives.
Yes, right.
And I assume that would be like through some sort of metering.
Well, this is okay. So the one that I've seen, and this is what it is modeled against, is simply a PVC tube. And this is meant for this is basically be a geotextile sock filled with some sort of a water applied product. Like in this case, it's the chitosan. So it's like ground up shrimp shell thing, right? So that would be suspended inside this kind of PVC tube. So it's just a place for the water to run across and come in contact with the polymer. And then you need a section of hose to allow enough contact time for the magic to occur before it gets to the bag. So that's all it is. It can be done in different ways. This is just trying to represent. That's all it's trying to do. Represent some sort of a injector location. But the one I'm most familiar with is that kind of really simple PVC tube concept.
We have one comment that there are clarity tubes, and I think you show a picture of one on your testing schematic on the left. Transparency tubes can buy for $65. Would that, Jane, would that be from like Ben Meadows or someplace? And then there's a question, are there polymer products that are on the DOT PAL that are not allowed by the DNR?
Okay, so the PAL only has land applied polymers or additives. Okay, so they don't get in the game of water applied. We're talking about water applied, and only DNR maintains. It's not really approval list. It's a list of products with the use restriction letters, I guess. But yeah, so there's a disconnect. DOT has the land applied polymers, and DNR has the water applied, and they're two different lists. And I think there's similar companies involved, but there should be different, most likely product names, because one's for land application, one's for water application.
Makes sense to me. Any other questions? Okay, well, Pete, thank you yet again.
Thank you, Leif. Appreciate it.
I really appreciate your participating.
Thank you.
Thanks much, Pete.
Thanks.
Yep. Bye-bye.
Okay, Nathan, I sent Nathan the presenter thing for him to load up.
Okay.
Yep.
Should I go ahead and introduce Nathan while he's
Sure,
getting that set?
You can get that set.
Okay, so the next presenters are Nathan Miner, who's grew up in Stoughton, Wisconsin. He's a graduate of UW-Whitewater. He started the Drainage Doctors with a focus on long-term BMP maintenance. He spent 13 years in the field inspecting, maintaining, and repairing all kinds of BMPs. And his co-presenter is Tyler Smith, who has a civil engineering degree from Platteville in 2004. He's worked in municipal, residential, commercial, agricultural, and mining stormwater engineering. And in the last few years, he's worked for the Drainage Doctors as an inspector, a designer, and an on-site manager. They're going to talk about their experiences in BMP inspection, maintenance of filters, and in-ground devices. Nathan, why don't you go ahead?
All right, you can hear me?
Yes, we
Can you hear me there?
Yes.
Okay, very good. Just making sure. All right, thanks so much, Leif. Yeah, we're here today just to talk a little bit about some of the different BMPs that we've done maintenance on, as well as done some inspections on, and just kind of give some feedback, kind of what we're seeing in the field, I guess, over the last however many years. So let me see. Oh, hold on. I'm having a hard time turning my page. There we go. So here's a list just of some of the BMPs that we do work with, done some maintenance on. There probably are other BMPs out there. If anybody has any questions on anything that we don't talk about today to see if we've seen it in the field or anything that we've come across, please feel free to reach out to us. There are other ones that we've done work with that just didn't make the list for this presentation. Just to get right into it here, the first one that we're going to go over is just a basic sump. Pretty primitive. Sumps are very basic, very easy to inspect, generally inexpensive to clean. From a maintenance standpoint, they're awesome for a customer because they're very easy to look at. In fact, some of our customers where we do maintenance for are able to inspect these on their own just by taking a measuring stick and sticking it down through the hole in the grate, as you can see up top, and checking the distance of the sediment buildup to the outlet pipe. Once that sediment reaches within 18 inches or so, depending on what the stormwater maintenance agreement says, then we have to vacuum it out. And the cleaning cost for that can be as little as, we've had as little as $95, depending on the size of the sump. And that can go up from there, but it's one of the more cost efficient from a maintenance standpoint BMPs that we have or that we work with. Next up will be storm scepter. Storm scepters are very similar to a sump, but they have the oil and grease port. I'm sure a lot of people are familiar with these as well. Pretty easy to inspect when you open up the grate. And actually I can kind of show a picture here. They can be a little confusing just based on what you see there. But you can open that up and reach down with a measuring stick to get the measurement of the sediment at the bottom. Typically what we do with these from a maintenance standpoint, if it's the first time that we've gone out to clean one, is we will vacuum it out right away. And that way we can measure down to the bottom of the structure and see what the size is if we don't have, even if we have a plan, because you never know if it was exactly what says on paper. And then that allows us to set a base point for future inspections and cleanings and whatnot from there. Same thing as a sump with a storm scepter. It's kind of nice because once you have that baseline, once you have to clean or vacuum it out year after year, whether it's say every 2 years, that typically stays the same. So a customer or a business owner can kind of count on that and budget for that. So every 2 years, let's say, if that's when it seems to fill up with sediment. Okay. So this is just to give an idea of the picture here. Here's the top of it. The other maintenance that we do with these obviously is cleaning the top of the storm scepter. There's not really any exciting pictures of the inside of a storm scepter, but that's kind of how they look. And they do have the oil and grease port, so that is vacuumed out as well when we clean out the sediment, getting the oil and grease out of there. All right. So moving on here to larger underground storage devices. Obviously, there are a lot of different types of underground storage devices. From a maintenance standpoint or from an inspection standpoint, really just trying to gauge the amount of sediment that these are holding is what we're looking for. And similar, as long as we can get out to these systems before they've been installed for too long, we can get a baseline measurement at the observation ports or collection points and kind of maintain that every year, trying to see how much sediment is building up within these. The biggest thing that affects maintenance on these though would be the presence of like isolator rows or collection points, as well as the need for confined space if for some reason we need to go inside. But isolator rows and collection points are amazing for maintenance perspective because they allow for a more consistent cleaning time. With those in mind, the sediment is being collected in a specific row or a collection point at the end, which allows for us to clean them more often, and it's going to keep the cost down for future cleaning, as you can imagine, 10, 15, 20 years down the road. Here's an example of a kind of a collection point with a weir plate. Sediment travels down in underground storage and is collected in here. We're able to then clean this out much like a sump, keeping the cost down versus having to jet something or go down inside something and move sediment in a more expensive way. One thing about the underground storage devices though, there's still a lot of, I mean, we've been doing, probably inspecting these for a little over 10 years, and I would say they're we haven't cleaned, we haven't had to go down in a large storage device and clean anything on a large scale. So from that standpoint, the longer term maintenance is nice because you don't have to do a lot. We're basically just checking sediment levels and things like that, at least with our current customers. But we have no idea until we get to that point, we know how much sediment's getting in there, but how much is that really going to cost to try to get all that sediment out of there at that point. So there's still a lot to be seen as far as some of those underground storage devices that we don't have collection points for or isolator rows for.
Hey, Nathan,
Yep.
I got a comment that it says the red dot pointer freezes the screen. If you hit the escape, it will free it up and turn off the red dot.
Turn that off?
Yeah, why don't you give that a try and see if that helps.
Is that open?
I think the freezes the screen may mean that you were having trouble advancing the slides.
Okay.
That's the idea.
Can they, is that it? Oh yeah, it is slow. I see, there we go. Hold on. There we are. Is that better? I'll try using the spotlight from GoToMeeting maybe. Wow, either way. It looks like I'm on the, I can see where you guys, I can see that I'm on the right here spot here. But so the well, I don't remember where I was, but I think I was pretty much done with the underground storage devices. But the whole idea, I would guess, from a maintenance standpoint, and I guess listening to Pete talk about design, is that designing a system, if you're thinking about designing a system, and I know it's more expensive to include sometimes isolator rows or collection points, it does knock down the cost and it makes it easier to budget for an owner in the long term. And it might be hard to explain that to an owner up front when you're talking about extra costs up front, but it does make budgeting and everything else easier from a maintenance standpoint. And the next thing we're going to get into here is, oh, I'm having a hard time with all these tools. There we go. Are the stormwater basins, and Tyler is going to talk a little bit about these.
Thanks, Nathan. Thanks, Nathan. You'll hear maybe kind of the theme of our conversation or our discussion here is more what's in the maintenance agreement when it comes to inspecting any type of BMP, and kind of what Pete was already talking about in his discussion is we really go back to those documents and read them thoroughly to determine really what we need to be doing when it comes to inspection and maintenance for any of these BMPs for our customers. Traditionally or typically we see for these stormwater basins that the inspection requires a civil engineer or at least a trained professional to go out and to walk these sites and to see what's going on. So it's really important to have a detailed maintenance agreement document because of who is utilizing them, and even one that's easily read, because we get so many different questions on what really does the customer need to do and the minimum they need to do. And obviously everybody's trying to save money, so it's really important to keep those as detailed and as I guess you could say layman's terms, if that's possible. One of the things that we typically see on a maintenance agreement is the requirement of a topo every 3 to 5 years. And really the benefit of the topo isn't just to get topographic information, really is to determine where is that sediment accumulation happening. And ideally we could catch the sediment accumulation before the whole pond needs to be dredged. Maybe it's just a corner of the pond, maybe it's just the area where the riprap flume is coming out of the pipe. So really that's what we're looking for, is maybe a corner of the pond, hopefully, versus the whole pond to remove the sediment accumulation. So I would say 3 years is a really good, every 3 years is a really good time frame. Maybe if we see that ponds are being filled in more frequently, maybe we would want to recommend every 2 years, but typically 3 to 5 years is a good time frame. One of the biggest things that we see, and we'll have some examples later on, is the woody vegetation. And it's a huge problem in almost every stormwater basin that we look at for the first time. But really, it's an easy thing to take care of from the very beginning. It's just simply mowing. So if you're developing maintenance agreements, I would be sure to include some very detailed mowing instructions, because that's a simple way to eliminate woody vegetation growth. One of the other areas that we see that needs a significant amount of maintenance is the riprap pads, the pipes, and it's because this is the area where we want to collect the sediment. So, it's often that a stormwater basin has a need to replace the riprap outfalls. And then we also see erosion around the riprap outfalls on the say the edges of them, and that's due to maybe some faulty installation practices or just massive rain events that we seem to be getting more often lately. And that's obviously not a good thing, because that's just adding to the sediment accumulation inside the basin. We get so many questions about cattails, and I'm not saying I have the answer on cattails, but typically the presence of cattails means that there is a shallow depth of water occurring at times during the year. So especially if we're working with biobasins or dry ponds, that tends to be a problem. That means that water is backing up for some reason. So it's something to keep an eye on as well. We also get questions on how are we going to restore this, and I think one of the things that, especially when it comes to bioswales or rain gardens or bio retention basins, one thing that we've been seeing a little bit more is the vegetative matting. Essentially, that's a sod that comes in a roll similar to sod, but it's more of the native vegetation plants. It comes with up to 3 foot tall native vegetation plants that can be specified per your project, and with the seeding in the sod matted area as well. I think that's it for stormwater basins, Nathan, unless you have something else to add.
Nope. No, we were just going to, next up here is just some examples of some stormwater basins that we ended up having to repair. This first one is a site called the Airport Road Project. It's out west of Madison. There's 3 large infiltration basins out here, and I'll try to figure out a way to show you where they are. But this picture right now that you see is a picture 7 years after construction. We had estimated through very close counting 1,800 small to large trees that had grown in the 3 different basins. And so when we talk about mowing, and the need for that's a very easy thing to avoid. The riprap had overgrown most of the areas, and there was a 1,700 square foot infiltration basin that was clogged and filled with frogs and tadpoles and cattails. The cost of repair on this was, I know it was over $50,000 just to bring everything back to in compliance with where it was supposed to be and where it was billed. Very simply, it could have been avoided with mowing and the normal annual inspections to make sure that these things are caught early on. And I've got some pictures here just to show. I'm going to see if I can figure out. But if you can you see my pointer, my mouse pointer, or no on the screen, Leaf?
Yes, I can.
Okay, so this is the 1,700 square foot basin, and you can kind of see the ring of trees going around it. This is another one of the large basins here in the bottom right corner. And then up at the top of the picture, there was another stormwater basin up here. And this is a look at, oh, hold on, gotta wait for you guys here. So this is a look at the southeast infiltration basin. This is the larger one at the bottom right. And you can see all of these trees that are inside the stormwater basin from left to right in the left picture. And in the right picture, you can see an area that's supposed to be armored with riprap. And that bundle of trees, there's actually an inlet structure going into the basin. It's actually an outlet from the other stormwater infiltration basin, but it was having a hard time with the trees growing around it. And we see that a lot, a lot of trees growing around the structures, because if someone is mowing, then they aren't mowing those, and the trees start to grow and they just leave them. All right, and this next group of pictures, this is going to be, wait for it to move. This is going to be the infiltration basin on the south. So it's the bottom left picture, just showing all the trees kind of surrounding the basin. You can see the cattails on the inside. And on the left, you can see a structure here. It is not allowing any water through. There's supposed to be some smaller holes allowing some of the water through, but it is all muck. Trees are growing all around it. No possibilities there. And then moving on, we have the southeast basin again. We have that same picture showing the trees. And just to give you an idea of all the trees that were within the stormwater maintenance, or within the basin itself, this was pretty much cleared. There's a few more trees we had to get out of there, but just an idea of the difference between the two. And how much easier it is now to maintain just by mowing and not allowing those trees to grow up in the first place. And this next set of pictures is the southwest infiltration basin. You can see where the soil below the basin, actually, there wasn't even engineered soil in this. It was very, very sandy soil. So it was really nice. The problem was we couldn't get, it was clogged. And I have no idea how it got clogged or when, if it was due to the construction, it was just never put back right, or if it slowly filled in. But you can see on the left, all the water that was sitting in there. We had to pump everything out. We lost a lot of frogs that day. On the right, you can see the basin dried right up, really nice. We were able to plant it. And you can see that the water now infiltrates just with the natural sandy soils that were there. So again, just keeping to the mowing theme. You can see here, just to show this photo again, when it switches, there we are, the before and after. So you can kind of see the structure down in the middle on the left picture, and there it is on the right. And we left one little tree when we were done, per the owner's request or the manager's request, so they could talk with their maintenance crew to show even little things like this should be removed, because that little guy right there would turn into a much bigger guy. And here is a final before and after of the repair. On the bottom here, you can see on the bottom left, you got the ring. You can see now it's all clear, the riprap, the armored riprap on the east basin. And then we didn't show really many pictures of it. Was you can see now it's cleared of all the trees that were down there. It didn't have any infiltration problems or any riprap issues. It was more just some overgrowth. So that is one project, and we've got another one here Tyler's going to speak to next. So Tyler, if you want to just touch on this one really quick.
Sure. This one is located on the east side of Madison, kind of near the airport. The existing site has 3 infiltration basins, and they work kind of in a row, so there's equalizer pipes between them. But essentially what was happening was the owners did not really know what these basins were. And so they were having some of their organic matter shipped off site in a fenced in area. However, that fenced in area also had the drainage inlets that drained stormwater runoff directly to these ponds. So all of that organic matter that was not making it into the trailers was making it into the infiltration basins. Of course, clogging the engineered soil, and then the water would start standing, and then it would start stinking. And apparently, several neighbors was at the time were complaining of the smell. So the owner is like, "Oh, I can fix that. I'll just throw in this little aerator, and we'll all be good." Obviously, it wasn't good, and essentially we had to dig out all of the engineered soil, even a couple feet of the sand layer, and returned it to original conditions with washed stone, engineered soil, and then bio basin plant plugs. The cost of the repair was close to $60,000 for these all three basins. In a sense, if they understood, if they were able to read a document that was very easy to understand and called us to inspect or called someone else to inspect, it could have been maybe taken care of for $400. So that's kind of the power of the annual inspections in a nutshell, of catching these things before it becomes an issue.
Very good.
I think we can move.
Yep. Thanks, Tyler. So just moving on here to another BMP, the upflow filter. And I know Pete talked about these a little bit. The kind of like an underground device that has a filter that needs to be changed out. The maintenance on these can be pretty extensive. The inspections are fairly simple, similar to a sump. We're checking the sediment level at the bottom of the structure. Generally doesn't require enclosed or confined space, but sometimes the larger vault, the vault systems do require us to go down inside and look and see what how much sediment is built up, as well as a visual inspection of the modules themselves, the module covers, and just making sure everything is still in place. The covers didn't float off. There's not, the mesh system didn't float out, that everything is intact. From a maintenance and a cleaning standpoint, the covers of these need to be removed. And I've got some pictures here to follow just to show you guys kind of what is all entailed. But once a year, as recommended by the manufacturer, the filter media needs to be taken out and reinstalled with new stuff. This obviously in a system where we can access it from right above. A lot of times we do not need confined space, but there are larger vault systems where we do, so that can increase the cost from a maintenance standpoint. Needing to go down there, it increases the crew that's needed as well as the safety.
Nathan, you're at about 5 minutes.
Okay, yep, we're good. So here's a picture of the upflow with the empty modules just to show what it looks like. You can kind of see all the way through. Just the cruddy bottom of the sump that needs to be cleaned out. And here is a picture of the filter bags, the dirty ones that were removed. Give you an idea of what they look like. They're quite a bit heavier once they need to be removed, as well as you'd expect, and then the clean ones ready to be installed. This is a picture of kind of a vault system. You could see the upflow filters go back to the back of the room down there, and as required, obviously the confined space and the specialty equipment to make sure everything's vented properly. And then here's a picture down inside. I was lucky enough to go down inside this one. You could see just the sediment buildup on top of these. Typically in this one, we were not vacuuming out the bottom. We were only replacing the filter media at that time. But typically we would spray the tops of these off if we were going to vacuum it out, just get them clean. But in this case, we didn't. And here's a picture of that system down below. Super fun to wade through all that water and whatever else is down there. Smells pretty good, but gives you guys an idea a little bit of what these systems look like a year or 2, 3 years after they were installed. And there's some of the covers taken off before putting them back on and putting the new stuff in place. All right, so that's the upflow filter. The next thing here really quick is the inlet filter. We have, this is a very basic, simple kind of filter, just sits on the top. I don't see a lot of these in Waukesha County. They're in Madison a lot, but basically these need to be cleaned 2 to 3 times a year with 1 oil and grease boom change every year. And just to show a quick picture of what they look like when this is on the left is an inlet filter that was out of compliance and hadn't been maintained for a really long time. You can see moss grows on the filter boom and everything's pretty gross. On the right is a replacement, nice clean oil and grease boom to allow the oil and grease to be absorbed. So these are cleaned 2 times a year to get the sediment out of the bags. The third is an inspection and cleaning as needed with the oil and grease boom being changed out one of those times. Pretty straightforward and very cost effective and very nice if you're looking for a solution when you're designing something, but low maintenance costs for a customer. And then lastly here we have just an example of a project using, Tyler's going to talk about this, taking an original design and incorporating the inlet filter and we were able to save a customer some money here. So I'll have Tyler take over on this one.
I think the idea with just showing this example is utilizing the technology that's available in order to meet BMP requirements. So on the left side of the screen, it talks about a bioswale being designed for treating runoff from a parking lot. The cost of that installation was going to be about $45,000 after they got done grading out the area, adding the engineered soil, all the under drains, and the structures for the overflow structures for that bioswale. Is the annual inspection, we figured around $400. Who knows how much it would cost to mow that basin. It's kind of a moving target at times. Mowing costs are. And then as far as any future costs to repair this bioswale, most likely including some sort of engineered soil replacement, which is not the cheapest soil on the market. So there are some unknowns when it came to annual maintenance costs, but we knew that if it failed and we had to rebuild it, it would probably cost at least how much it did for installing it, about $45,000. So the owner came to us and asked us to do some thinking outside the box, and that was no pun intended. And so we kind of looked at these inlet filters as a good way, working with the county, Dane County, as a way of meeting the requirements for oil and grease and for sediment control. Essentially, this bioswale we split into 2 separate sections and added a inlet filter with structure for each section, draining this, collecting the stormwater runoff from these parking lots. And essentially the cost of installing this was a fraction of the bioswale at $15,000. And then some costs for the annual maintenance would be $480 for actually cleaning these, which there's the maintenance or the manufacturer recommends inspection and cleaning 2 times a year, and on at the third time, replacing the oil and boom products inside the filter bag. Again, the mowing cost would probably be about the same as far as an annual maintenance cost. But the great thing is there's no engineered soil that would have to be replaced, and it's really just a grassy swale collecting the water into these and conveying them into these structures with an inlet bag. If we had to replace the inlet bags because they failed, we're talking very minimal pricing to do so for each bag.
And I think that's it. So I just want to thank everybody for listening. If you have any questions, obviously feel free to write them or reach out to us by email or phone.
We have time for a couple of questions. Here's one that was texted in. Have you seen sediment in chambers that are not isolator rows? For this regarding underground storage devices.
Yeah. Yes. But I guess the question would be, was there an isolator row there in the first place? If there's an isolator row there, they do a really good job of, isolating like they're supposed to. So there might be sediment that we come across in other rows, but it moves through pretty well. So we don't see like large amounts of accumulation. Obviously, if there isn't an isolator row, then there is more sediment in the other rows. I guess the best way to explain that.
Okay. And then a comment says the recommended topo survey frequency for stormwater wet basins 2 to 3 years seems too frequent for a wet pond. Also, frequency is dependent on the depth of the storage section of the wet pond as well.
Yeah, I think we don't recommend the frequency. It's actually listed on the actual stormwater maintenance agreement as to how often it's supposed to be, whether it's typically we see 3 years or 5 years. So we're not necessarily going to customer and recommending something. It's pretty clearly written on the stormwater maintenance agreement when it should be done, depending on the BMP.
Okay. I have one question I would have is for places where there's potentially some oil and grease in the runoff, like a service station, and there's a inlet that has a baffle pipe in it, do you think that they work?
Tyler, what are your thoughts on that one?
Have you cleaned some catch basins and like parking lots and so on, and actually found floating petroleum in the catch basin, or do you think it just gets blasted through?
Do you mean like with a filter, an actual filter, or you did like the storm scepter?
Yeah, I guess the storm scepter or something with a baffle, like a snout is one brand, and
yeah,
I'm sure there's others out there as well.
I haven't seen a lot of those, but I know with the storm scepters and some of those, there's definitely oil and grease that we're getting out of there. But I do wonder that myself too, because it's, when you go down and you start cleaning things out, you're mixing the water and things are moving around a lot. But I guess I haven't seen specific BMP or a situation where it would just be floating there. It's usually caught like in a storm scepter or something like that, where we're vacuuming it out and it's caught in that tube, so to speak, that's raised up higher than the rest of the water.
Okay. I have one last question, then we should move on. For the bioswale and inlet filter example, how was the TSS removal calculated?
So what I didn't mention on that project is there was on the down slope side of the swale where the inlet filters were installed, there was a wet pond, and then also an infiltration basin to meet those requirements. So there was a wet pond also designed on the site. However, from the parking lots, it's intended that those bags would collect the sediment. There's the site was an extremely large site, and there was lots of other areas draining to that wet pond, more so than this parking lot that we were treating.
Okay. Well, we should move on to our next presentation. So I really appreciate your taking the time to join us today.
Thanks so much. Appreciate it.
Thank you.
Thank you.
Okay.
Penny, should I go ahead and introduce
Sure.
the next speakers then?
And John, I sent you a link. So go ahead.
Okay.
John, is it okay if
All
I
right,
you and Kier at the same time?
Sure.
Okay. So, and you're going first, I think, right?
Yes.
John is.
Okay. All right. So next up is
All right.
John Seatman. He's the development manager for Seatman Realty Corporation. John is a part of the third generation of the family business, which was established in 1943. He is active in entitlement, construction, and maintenance activities for all projects, which include commercial buildings, retail centers, and conservation subdivisions. John is also active with the Metropolitan Builders Association as a past president and is still serving on the board of directors. And then following him will be Kier Peckham. Kier began his career in 1990 working for a native wetland plant and seed nursery in Muskego. In 2001, he established Natural Landscapes, Inc. Kier continues to get his feet wet and hands dirty with the installation, management, and monitoring of native prairie and wetland restoration projects. His clientele includes municipalities, engineering firms, general landscape contractors, grading contractors, developers, and private landowners. The bulk of his knowledge has been acquired from the successes and failures of numerous natural landscaping projects throughout the past 29 years. And they're going to tag team a presentation about basin maintenance, vegetation management, and homeowners associations.
All right. Here we go. Thanks, Leif. This is John Seatman. Kier, please chime in if you have any input on what I'm providing here in the presentation, but we'll just get right into it. I'm going to talk about the years of experience that we have, mainly with subdivision construction, but really we've dealt with stormwater management facilities, as we call them. We don't call them ponds because people expect them to be waterfront property when we call them ponds. So we just call them stormwater management facilities and get right down to the nitty-gritty of the utilitarianism of these devices. But we've done these, as Leif mentioned, in all different situations, and they're a source of great frustration for many people, especially once they get to the homeowners association and we get down the road 10, 15, 20 years. So we really try to get people set up for success, and when we manage an association, which we currently manage about 4 homeowners associations, and we advise countless ones that continually come back to us for advice on these things. But really our 3 big things are to remove the woody and invasive plants. Tyler and Nathan did a great job just before me talking about all of those features and how expensive they can be to remove later on. To repair any erosion, and then really on top of that, maybe most importantly from my presentation, is the management of homeowners' expectations and how they should foresee this working in the future, what our timelines are for growth of native species on the pond banks and things like that. And I'll get into it in more detail as we go along. But I think it's very clear that woody plants are maybe one of the biggest and most expensive issues that we come across in ponds or stormwater management facilities, and these plants are typically cottonwood, willow, dogwoods. It can be any number of things. It can even be box elder and buckthorn. But they're usually easy to get early on in their life cycles before they're an inch in diameter, and it requires chainsaws. As everybody said earlier, get these things taken care of early. So we really, really push our landscapers. We have it in all our requests for proposals for our projects for any kind of maintenance that they include. Less mowing of the slopes to the ponds, but always woody plant control. And that's usually 2 times per season, just cutting and leaving the debris in place and treating the stumps. And 2 guys can go around most subdivisions ponds in a day, spray any woody species that get out there. And if anything starts getting really big, it's pretty noticeable and can be cut down at a later date. But for the most part, that's as simple as we get. And the reason we do that is because if we take away the integrity of the pond slope vegetation, then we invite geese and other waterfowl into the pond, as well as more nutrients. And I'll get to that shortly. We always look out for erosion. Erosion issues are obviously a big issue and can create huge expenses. We have experience in lots of clay lined ponds, rubber lined ponds, EPDM lined ponds, and just straight up topsoil lined ponds. And they all have their own special quirks, and they all erode at a certain very distinct rate. And so you can see in this photo, this is a pond that has manicured grass right to the water's edge. Not recommended in any case. Number one, because bluegrass is not a very good soil stabilization product, but also that it invites all those waterfowl, as I mentioned, right to the water line, which creates more issues later on. The manicured versus native vegetation argument is pretty easy when you show a photo like this, and I think we've all seen ponds the day after or 2 days after a big rainstorm, especially this time of year when everybody's applying fertilizer and treatments to their lawns. It really doesn't take very long, even a matter of hours after a storm, and you can see a nice layer of algae growth on ponds in very short order. And this is what everybody says is so ugly, and it's easily avoidable with a few good practices. And as I mentioned earlier, we talked about managing homeowners' expectations, and it's super important that everybody knows that when we plant a wet mesic prairie around a pond, that it's going to take 5 to 7 years to get to the point where you could take pictures like these in that area. And a lot of those seeds take several years to germinate. I think Kier's probably going to talk more about that. He's much more of a plant expert than I am. But I enjoy the look of it, and it's something that we have to sell to our customers when we sell them lots or when we sell them a property, and it includes these types of vegetation. The worst thing that can happen is they come in and mow it down and manicure it to the water's edge, which sort of takes away all that hard work of getting it to this point. But these native plants are exceptional at nutrient absorption before the water even gets to the pond, before it becomes an issue of dredging and further maintenance later on. So we tend to take a holistic approach to our stormwater management facilities. And as you can see here, we've been at an advantage because we've been developing conservation subdivisions for many years, which include lots of open space. And that open space can be used to infiltrate that stormwater much more so than if these homes were directly up against this water management facility. But we like to get that pond edge naturalized with that native vegetation. And we even go as far as having that buffer or should I say, much farther away from the water's edge than what's typically specified. It may not be the top of the slope, it may be another 50 or 100 feet beyond that top of slope to increase it even further. And if you do it nicely and you grow those nice flowers, people get pretty excited about it. But they're not so excited about waiting for those to come. You know, the 5 to 7 years is not most people don't have that kind of patience. So you just have to keep coaxing them along that this is a good thing, and in time it will save them a good deal of money. Kier we've worked with Kier for a long time, probably I think since the beginning. And one thing he always professed was to get emergent vegetation in place. And I know Pete touched on the subject a little bit earlier, that the jury is out on the effectiveness of this, but I can tell you from our experience that the nutrients that are collected in these planting pockets that we create are certainly captured and taken up by these emergent plants. And this is a picture of a pond we have in the town of Delafield that is our favorite pond, and all of the attributes of the perfect pond are here. You've got really steep bottom slopes in the pond. You've got depth. It's about 20 feet deep. It's got about a 1-to-1 slope from the safety shelf down. In fact, this was one of the first large-scale projects where we did have an inverted safety shelf, where we have it 10-to-1 going back toward the shoreline rather than into the pond, and it creates a nice pocket there for these plantings. And we filled it with small river stone and emergent plants, and even topsoil, which is forbidden for the most part. But Kier convinced us it would work, and it does. But it's not just plants. We created more of an ecosystem here by stocking this pond with fish, just to have something to eat up and sort of recycle a lot of those other algae components and other things in the water that can be processed by something other than just bubbles. So we talk about being proactive in pond maintenance. This is for wet ponds, like you see on the left, and also in dry basins, as you see on the right. The one on the right is one just like we saw in Nathan and Tyler's presentation. This is an obvious overgrowth and a troublesome issue, and that landowner is going to be spending a lot of money to remove all those plants and restore that facility to its design standards. Pond maintenance, we put a lot of dye in ponds, unfortunately, and it really is, it's sad because most of it washes downstream, unfortunately. But these are things that can be minimized if you grow the right things around the ponds and you treat the water before it gets to the ponds in such a way that it's cleaner when it gets there. Lots of forebays and wet cells on the way to the ponds are very important. But we've worked with a lot of pond maintenance experts, and they'll tell you that not every pond should get dye. Not every pond should get aeration. Not every pond should get a fountain. Everything is different. If a pond is 4 feet deep, it's not efficient or cost effective to put in a diffuser or even a fountain. We all know what these can do to suspend the solids in the water, and they can affect infiltration areas in the area. So it's important to take each one of these on a case-by-case basis. And many times we don't know how the maintenance is going to look until it's in place and functioning for a year or two before we get a solid approach to the maintenance and the long-term maintenance of the project. We always have weeds. We always have algae. Algae can be cut to a minimum, usually by agitating the water surface. The weeds, we're fortunate enough that we've not seen a lot of milfoil in our ponds. They're usually small enough and hot enough in the summer that they don't accumulate a lot of those. But we have had a bit here and there of other weeds, lots of other things that can just fill in the water column and eventually turn into sediment at the bottom that requires dredging. We have a lot of muskrats in many different places. They're enormously destructive, and they need to be removed from these areas if they become an issue. They're relatively easy to trap and remove, but it is another cost, and it's sort of an unknown cost for the associations to incur They just don't know how to budget for those things. So we always leave an earmark of a certain amount in these budgets for rodent removal. And I think we're going to see a presentation on this in the next day or so, so I won't go into that any further. But geese are probably our biggest enemy. They introduce the largest amount of nutrients into these ponds, and we spend, as you'll see in a moment, a huge amount of money to keep these birds away from our ponds, or our stormwater management facilities, excuse me. And you can see there's so many ways to deter them, but it takes sort of an army approach to do it. As you can see in the photo on the lower right, there's a flock of geese there 25 feet from a swan decoy that was placed out there to scare those away. So you can see how ineffective those are, unfortunately. It's a cheap way to go at it, and maybe it works for a little while, but it's not effective in the long term. Our biggest success with geese has been with dogs, and there's a couple of contractors that are local here in the metro area that provide dog services to scare these geese away. They are certified and licensed by the DNR to do this work, and it is a very large expense, but it's very well worth it. It's much cheaper to do that than to remove all the effects of their droppings over time. So our largest expenses as homeowners associations come out to equipment maintenance, and pond maintenance, and goose control. And it's typical, this is a typical pond, 3/4 of an acre. Many of you may have seen this slide in the past. This is maybe 2 or 3 years old, but we spend about $750 to power the aeration system. This is a diffuser. The dye and algicide comes out to $4,500. It's about $200 a quart to put the dye in. That's just the cost of the material. Obviously, there's labor and trip charges involved in that raise that price up. And algicide accumulates enough or incurs enough expense to raise that number up quite high. Goose control, we budget $7,500 a year for an entire subdivision. So this isn't really true for a 3/4 acre pond, but this is for 2 other ponds, including this one. I would say between 2,000 and 5,000 would get it done for a pond of this size if it were just singular in a development. Equipment storage, you have to put this aeration equipment away for the winter and keep it in good condition so that it's running. So you have to change out filters and vanes and things like that. That's about $800 per pond. And then just general maintenance around the pond of the woody species. It comes out to be pretty cheap relative to the other items. And I think that's a high number in this case. I don't think that that's a huge expense. If it's done on a consistent basis annually or twice annually, it can even be less. So with proper planning and maintenance, you can increase the pond performance. You can increase the property values if you're not sitting with a house next to a stormwater management facility that's filled with cattails and muddy water. You can reduce maintenance costs over time and make for very happy homeowners. And good design. I didn't go into design of the basin in great detail, but I'm happy to share with anybody that is interested more details on our Lakeside Conservancy Pond in the town of Delafield. That's the one that we think is the pond of all ponds. And I use pond in that case because that really is lakefront property. When you look at it, it's worth looking at. It's not a big muddy pond. And if you keep this native vegetation in good shape, the expenses can be really, really low over the long term. We've had only a couple of communities or neighborhoods that had to dredge ponds, and it's been extremely expensive. These ponds are not very big, and they cost anywhere from $45,000 to $100,000 to do the dredging work, and that's a long-term expense that is very difficult to forecast for. And in spite of our best efforts, even if we keep a small amount every year as a capital reserve account, that one would be really tough to catch up with. So with that, Leif, I'll open it up to any questions. And Kier, if you have any comments, I'm happy to throw some in now.
I'm not seeing any text comments, but you gave me a brilliant idea that's going to make me a wealthy man.
Excellent.
Control swans. I could sell them for $1,000 a piece, and just have them motor around in the pond and scare the geese away.
Although they weren't working very good in that slide, John.
Pardon me?
It didn't look like the white. You're saying the white swan. Yeah, it didn't look like it was working so well in that slide with the geese all looking at it.
No, that was my point, that the dogs are much more effective than the
Right.
But that's because the swan is stationary, and if you just put it in like on an RC car or something like that and chase the geese around, they'd scram.
There you go.
Yeah.
Patent that.
The other thing with the geese, in my opinion, is the food source, and that goes for any wildlife. If you can eliminate the food source, which is turf grass, then you might be able to save some money. Because that goose maintenance, annual maintenance, to keep the geese out, look pretty pricey. That on top of the turf maintenance even makes it worse. So converting some of these turf areas into natural, shortgrass prairies or mesic prairies, sedge meadows and things of that nature might deter the geese from being there if there is no food.
Absolutely.
So,
John, you mentioned $45,000 to $100,000 to dredge a pond. I presume that's like a half acre or something like that.
Yes.
If you had to do that on, say, a 20-year cycle, presumably the homeowners would have to be putting away a kitty of $1,000 to $2,000 a year to pay for it.
Yes, and that's the trouble, is that it's really challenging. You just don't know what to expect. But I think when we do all of these preventative maintenance, or all this maintenance that I've been discussing and what Kier's going to talk about, is that if you get ahead of it, you shouldn't ever have to dredge. And dredging is a last resort. And it's really sad to see when it happens, because it's usually an association that's gone, for the lack of a better term, rogue, and they've disregarded our advice, and they just continue to carry on and let it overgrow. And then they see situations like what Tyler and Nathan showed us, where you've got to bring a backhoe in and remove all the vegetation, and it costs a fortune. It shouldn't have to be like that, and it doesn't have to be that way. But some people just blow us off, and they don't listen. But I agree with Kier that the more natural you can get, and the more nature that you can invite to the site, the more it'll balance itself out with invasive species and other things, and especially birds. You can do these things and have a beautiful looking place and an effective goose and invasive species repellent at the same time. And then you have a pond that's healthy and doesn't require any dredging maintenance in the future.
Before Kier starts, there's one more chat question. Since pond side slopes make up only a small portion of the area draining to a pond, what the neighbors are putting on their lawns seems a much larger factor than pond side slope vegetation for algae generation. Any tips for how to encourage neighbors not to over fertilize?
Well, I think Kier is going to talk about that, just naturalizing the backyards of all these places. If everybody put a 20-foot filter strip in their last 20 feet of their yard, I think you'd have an incredibly effective buffer between that and any water downstream. Everybody has a different view of what a prairie should look like and what grass should look like. And it's about 50-50 from our experience. And half of these people just don't want to see tall stuff. They call it weeds. And I call it incredible natural stuff that I don't have to mow or treat with any chemicals. So I think Kier can talk about it more here.
yeah, one person's prairie is another person's weed patch. And it all comes down to educating people and getting them hooked on what native vegetation has to offer. There's a history behind it, and it belongs here, and and it can add a whole nother dimension to a backyard. We have plenty of turf everywhere, and with the issues of the endangered bumblebees and honeybees and everything else that's occurring now, it's I think we're starting to make nice small baby steps in the right direction, and making people aware of what we can do to make it better. So with that, I guess I'll start. Can you see my screen? I'm a rookie at this here, so.
Yeah, you're good to go.
Okay, sounds good. So I might be a little biased, but you know, vegetation is everything, right? It's a very important aspect to all these stormwater facilities, and if it's installed properly from the beginning, I think it's going to solve a lot of the maintenance issues that we're looking at with some of these older basins, including the cattail, you know, invasion and things of that nature, and the woody vegetation. So that'll be mentioned again in my slide presentation. So once a site is constructed, we can look at the plans and say, well, it's going to be dry. But is it really going to be dry? That's the big question. It's site specific. It's dependent on the weather and what Mother Nature throws at you. The soils could turn out to be a little bit different. I think rolling with the punches and analyzing the site is step one. But I think more important than that is overlapping seed mixes, both wet and dry, to assure you that whatever scenario Mother Nature throws at you, whether it's 500, 100-year flood or the drought, you'll be covered in each scenario. So that's very important, overlapping seed mixes. Why is this not going next here? Looks like I'm having the same problem Nathan had. Okay, so retention basins, I'll get into this real quick. To me, retention basins start out with the emergent zone. Retention, it's retaining the water. The water doesn't seem to fluctuate as much, makes it easier to establish vegetation. It starts at the water's edge. Emergent vegetation, like the picture on the right or on the left, is arrowhead, Sagittaria, and then native bulrushes, soft stem bulrush, and burreed. Those species are incredibly important for stabilizing that shoreline edge, whereas turf grasses, you know, a lot of people like to mow, and of course this is happening, and so keeping turf grasses and keeping away from the, one second. Okay, so I'll be on the news here for sure now. So anyway, retention basins, establish that zone, the emergent zone, work your way to the wet meadow zone and up to the side slopes, which is the drier zone. So you really have three zones. The wet meadow zone overlap with the upland zone, and you'll be pointed in the right direction. Also, wetland rootstock is incredibly important. It can be rootstock, it can be plugs, you know, purchased from nurseries. Wetland plants have horizontal root systems, and they reproduce vegetatively very quickly. And it starts at the water's edge. And in detention basins where you have a lot of fluctuation, as you get into the summer months and the water levels go down, those plants will send rhizomes down the hill further into the shelf. If there is a lot of flooding, then those plants will work their way up the hill. So as long as they're all connected, they're going to survive, and that zone becomes healthier and healthier. These two basins here are young. The basin on the left, you can see the water where it was, and you can see it was in midsummer, and you can see those wetland plants reproducing vegetatively. They're all connected. There's 4 species in that picture, 3 square bulrush, burreed, and soft stem bulrushes in there also. So, and the picture on the right is actually an infiltration basin shortly after it was constructed. You can see some of the native seed is starting to kick in. That is a 15-year-old basin roughly, and today it is dry. There is no water in the bottom of this basin whatsoever. And I think that is a testament to the value of vegetation. The roots break up that sediment and allow for that water to infiltrate. So you have to roll with the punches on these projects where you get that heavy rain and it kind of sets you back. So there's no need to panic. Again, same thing as a retention basin. Native seeding is incredibly important up above that wetland emergence zone and then into the dry prairie zone. Infiltration basins are a little bit different of an animal. A lot of sandy soils, engineered soils. Engineered soils can be tricky to establish vegetation. Again, both wet and dry mixes are very important. We don't know for sure if it's going to be wet or dry, so put them both in there and let Mother Nature figure it out. Vegetative matting works very well for quicker results. Bioswales, just another step in the right direction for managing stormwater runoff. And bioswales can offer a variety of native wetland plants. You can have a wetland to a sedge meadow to a shortgrass prairie in one bioswale. Again, overlapping those seed mixes really is beneficial and assuring you project success in the future. Rain gardens, another step in the right direction. For people with drainage issues in their yard, instead of bringing in the grading contractor and making it an expensive situation, it can be utilized and used as an opportunity to introduce other landscape rooms, I suppose, or aspects of your landscape. Shorelines, oops, I skipped on here. So then there's shorelines and shoreline buffers, many different scenarios based on your shoreline. Boat traffic is a big issue. Are you in a bay or not? Wetland emergent vegetation can be incredibly beneficial to your lake, as well as your shoreline and wildlife habitat. And then there are others like the photo on the right, which is extremely steep sloped, right next to riprap at the water's edge. Vegetation management is site-specific, species-specific. It can be selective managed. Selective cutting is one of my favorite management tools, using weed whips and mowers, but mainly weed whips in these tricky areas where it's very wet. Expensive equipment shouldn't be near these zones, so you want to do it by hand. It instantly eliminates these species from view, and it encourages other species to grow, to compete with it. And in my opinion and my experience, it's an excellent management tool. Utilizing native plants to compete with the invasive species is the name of the game, in my opinion. And it can be done year long, spring, summer, and fall. My least favorite is herbicide application, of course, with teasel these days. If somebody isn't familiar with teasel, it's T-E-A-S-L-E, and it's incredible. It's a biennial, and it wasn't even in Wisconsin 20 years ago, and it's here and it's all over. It's along the highways now, and unfortunately, herbicide application is necessary. It's also necessary for converting lawns into native prairies. Mowing is an excellent management tool for cattails where you can mow. Track loaders are helpful. They seem to float on top of the vegetation very well. Can be performed summer, spring, fall, and winter. I love to winter mow. When the grounds are frozen, it thatches up the biomass, mimics fire, and sets back woody and invasive woody species, which we keep talking about all day. And that is really important, because nature's way of managing the land way back when was fire. And obviously we don't have that opportunity everywhere anymore. So the next best thing is mowing. And this is another example of woody vegetation. And, this is what a basin will look like if it hasn't been taken care of for 3 to 5 years. And once it gets to the point where the picture on the right, it can get very expensive. Then that's when the chainsaws need to be brought out and the chippers and the crew, and then you can end up spending a lot more money. So a little bit of maintenance goes a long ways. And there's my contact information, and that sums up my presentation.
Great. Have a couple questions that were chatted in. What is an approximate cost per acre for wetland restoration plants using?
Approximate acreage cost for seeding, for the materials, the installation, is roughly around $1,500 an acre. That's on the low end. If there isn't any, if the grading contractor is performing the grading and he's doing the topsoiling, and there isn't any soil preparation other than maybe Harley raking or disking, or harrowing, then you're looking around maybe $1,500 per acre for an upland. It gets more expensive when you get into the wetland zones because those seeds are more expensive. So you're closer to the $2,500 per acre mark. The good news with the wetland zone is it's a smaller zone, so the acreage is smaller, so that helps out.
Okay.
For planting emergence and plugs, that can be about the same. $1,500 for a 1 acre pond should cover the rootstock and or plugs.
But that's not, you're just doing a strip around the edge. So if it's a 1 acre pond, it's actually a fraction of an acre that you would be plugging.
Correct, because that zone is very narrow. Correct. So if you put 1,500 linear feet, one rootstock or one plug per linear foot, let's say they're $1 a piece. That's a low end probably, but you could go less plants. The nice thing about the wetland edge is, the wetland emergence is they reproduce quickly, and so you can get by with using less plant materials.
Is 25 plus acres too large of a project for restoration in hydric soils?
I wouldn't think so. Mud flats or wetland soils, if you can get in there in the wintertime when it's frozen, if it's a clean slate, if it's freshly graded, that's an opportune time to seed those areas, and they can turn out incredibly successful with diverse seed mixes. And native seed has come a long ways from when it was 30 years ago when we were hand picking the stuff out of ditches. So it's now tested for germination and purity and everything else, and they're very diverse mixes. So you have pioneer species with the annuals, biennials, and then you also have perennials, and those are the ones that show up later on the site. And those are the species that are going to outcompete your weeds.
Okay. Another question. When you say winter mowing, do you mean when the ground is frozen, which I suppose means midwinter or later, or does winter mowing mean just once the growing season ends?
Here, did you hear that?
No, I didn't.
I'll read it again. When you say winter mowing, do you mean when the ground is frozen specifically, or do you mean just after the growing season ends, which I suppose could be end of October?
Yeah, it can be a combination of both. But I even mow in the springtime. Based on the species you're targeting, if it's a cool season grass like reed canary grass, and it's a monotypic stand or whatnot, I'll mow it in the springtime, or even wait until the summertime for giant reed grass. And promoting species diversity, again, trying to mimic fire, trying to target, and control the invasive plants. So depending on the equipment that you have to be careful. It's scary it's stressful if you're going to be mowing the wetland in the spring. And sometimes it can't be done. So, but at least the end of the year mowing, yes, when the ground is frozen, even wetlands don't freeze so well in the wintertime. So you got to, again, be very careful.
I saw you had, in one of those pictures, I saw a tracked skid steer.
Yes, those do a great job. They can still get stuck in the right scenario if it's, there's no bottom to these mucky areas. So I didn't think I could get stuck, but I've been stuck before, and it's not fun.
And in the pictures, I couldn't tell, do you mulch mow and leave the cuttings in place, or do you bag it?
Yeah, the rough cut mowers and the brush hogs do a really good job with thatching up all that plant matter. There really isn't enough there to rake. If you did rake, I don't know if it would even be worth it. You still have leaf litter, but again, that material biodegrades quicker, and then the following growing season, you're more focused on the new growth, and it's a brand new world. So, as long as the mower does a really good job with thatching everything up, I mean, you don't rake the ashes off of a burned prairie, so there really is no need to do that with a rough cut mower when it does a really good job with thatching up that plant matter.
Okay.
Leif, can I just add one thing?
Sure.
Keir talks about fire and mimicking fire a lot, and it's really important that everybody in our subdivisions would love to burn their prairies, and it would be fun, and fire is fun when you're controlling it like that, and it does some amazing things, but it really can be detrimental to a prairie and really destructive to a neighborhood when one guy is downwind of everything and breathing in all the smoke for 4 hours. But even better, if you can mow it, then you don't disturb the ground, and when you leave the ground exposed after a burn, Keir can tell you that you're opening yourself up to all the seed that is in that seed bed, including the good stuff and all of the bad stuff. Those things will all germinate, and you'll kind of start over. So fire isn't always the best thing. It's highly effective in certain situations, but especially in subdivisions and industrial parks, it's not perfectly conducive to the areas around it, just from a living with the situation and the smoke issue. But it also leaves you somewhat vulnerable to growing the wrong things in the place of the good things.
Yeah, absolutely. Fire can cause a little bit of disturbance too, so you might encourage, things like Queen Anne's lace and sweet clover as a result. So maybe in some cases mowing might be better. Also, you're at the mercy of the wind direction and the people that are involved and the volunteers and the cost of it. So especially in these municipal areas, mowing's a phenomenal management tool. But however, woodlands and buckthorn management and, oak savannas and things like that, they need to be burned. So you're right. There's a time and a place for each type of maintenance.
Have either of you been able to do many burns in the Waukesha County area?
I don't do burning. I normally refer that out. But I lived in a woodland in Pewaukee that was burned every other year, and it was incredible. People would ask, why isn't there any buckthorn here? Well, because it's burned once a year, and the big trees were fine through that, and the native vegetation and the spring ephemerals were off the charts. One of the nicest oak savannas ever. So, but there are people that
the people that are doing it manage the permitting and public relations process?
What's that, Leif?
Do you have any idea, whoever was doing it, how they managed both the permitting and the PR process?
Yeah, I think they however they acquired their permits, they would do so and notify the fire department and the local municipals and things of that nature. So for when people would call, because people will call.
And Leif, we haven't had too many burns in our subdivisions, but I've seen many projects that have burned, and it sometimes it can have an incredible result, but it takes, like all of these things, it's a lot of work. Kira and I prefer mowing over burning, but there is a time and place. I have an oak savanna behind my house and some common open space, and I can't get it to burn because there's not enough tinder there to light it up as much as I would love to, because it's growing a nice lawn of 4-inch high buckthorn that the only way I can really control it effectively is to burn it, and that's a challenge. So everything's very site specific, and not every place can burn, and some can burn really well.
Absolutely.
The county parks department typically burns, I think, 35 or 40 different properties. Most springs, they're not doing it this year, but they normally do that. But in that case, they've got a significant buffer between the parcel that's being burned and the nearest houses development. Well, I'm not seeing any other questions, so I think I will, Penny, should I turn it back over to you and let you wrap up?
Sure. Well, thanks, Leif.
I just want to thank you very much, John and Kira. I really appreciate your helping out.
Thanks for having us.
Yeah, it was great.
Yeah, thanks for having us.
Thank you. I did send out in your chat line the little survey link to fill out if you could, a little evaluation of today's presentations. If you could fill that out, that would be great. And Kendra or whoever from Waukesha County, when they send out the PDH certificates, they're going to be sending that link as well. Just make note that tomorrow is a different link, so you do not use the same one that you used to get on today. Each day has a separate one. So tomorrow we'll have one, and Thursday we'll have a different one. And I think that's about it. If you have any questions, you should have all received emails from me, so you can just feel free to contact me at any time. Otherwise, have a great evening, and we'll talk again tomorrow. Thank you.